Hey, what's going on, guys? Last time we started setting up the stuff for the reactor, and in the meantime, I started getting more titanium in order to finish the boiler, and also I have moved everything down a little bit, and also kind of aligned it to that wall there rather than kind of aligning it there. I just wanted it to be more accessible to me so I could kind of come by, read the sensors more easily, do maintenance if I have to. The only difference is going to be really for the heat exchanger and everything, and also these universal extenders are going to be down a little bit, but that's really not a big deal. I prefer to have more easy access to the reactor itself and potentially to see the sensors here and everything. It's just more so for accessibility. I was thinking of using scaffolds potentially, but I don't know. It doesn't look as good, I think, with the build. So for now, we'll keep it at floor level, and I think eventually I'll have sort of I don't know what you would even call it, but like a more traditional reactor build. So I'll have like a couple reactor cores like in the middle here, and then I'll have all of the infrastructure to extract the power sort of aligning on the outside just to make it look a little cooler. But for now, we'll do it the simple way because I need to start getting the different fission products and the byproducts from the fuel rods and everything. So let's finish moving this guy down. And I also want to move the fluid stuff over here, I think. So we'll move this drum over one. So we'll put his carbon fluid pipe pointed into here. We'll put him there. And we'll move this guy over one. There we go. And we will have our little fluid sensor right there. Good. And then we need the neutron, or the Geiger counters rather, there. That's another reason why I wanted to move that one back as well, is so that we could have more Geiger counters on the main reactor, and then that way we have these spaces down here available for item pipes, because eventually we're going to want to extract the spent fuel rods and the breeder rods. All right, so that is good. For now, we can cover this up because we don't really need access to the bottom of the reactor right now, but eventually we will put extractors there. All right. Now we want to set the faces. So for the primary faces, like we said last time, it is the regular wrench, and we're going to point them down because we have the universal extenders there. And then for the secondary facing, we'll go pointed that way, and then pointed down on the last one to remove the blue face, and we can see inside. The faces there are connected. Very good. All right, and then this guy's here. I also have another thing full of molten tin just because the reactor cores have buffers of 64,000 liters. Yeah, you can see there. So the primary tank, tank 0, is the coolant tank, and the tank 1 is for the hot coolant tank. So because there's 4 of them, that's going to take 256,000 liters, which is the capacity of this drum, which is also not full. So in order to have a little bit more than 100% fill, because I want to be able to detect if this goes below, I got this other drum, and we will allow this to fill when I'm ready. So yeah, basically what we'll do for sort of a safety feature is to detect if this tungsten steel drum goes to 0%. If it ever hits 0%, we're going to turn off the reactors. Also, we're going to put the fluidometer and the gibbelometer on that guy. That's a Geiger counter. Don't I have? Oh, yeah, I do. Fluid sensor, we'll put that here, and then we'll have a Gibble sensor there. I think we'll put them like this up here. Right. Okay. So now we can put the reflectors back. So 1, 2, 3, 1, 2. I think that's good. All right. And then, oh, another thing I did is to change this dryer to an Invar dryer because it wasn't really fast enough. And also, let me start setting this up here to pump in the fluids. There we go. So that guy's going to start filling this, what do you call it, this boiler here. So let me set this boiler now to percentage mode. Oops. Percentage, there we go. So yeah, we want to be able to detect what percent that's filled. Although it doesn't seem to be filling. No, it has stuff in there. Oh, it's probably measuring steam. Okay, I will have to, yeah, I'll have to measure the fluid count off of that guy, which is fine. I can do that. Let me see if I can set it down. These are always like really finicky. Let's see. There we go. So yeah, now we can detect what the fill level is of this drum. So there's a pump on the bottom there. I think I put that there last time. And yeah, so I upgraded this guy to Invar so that he can create more distilled water at a time. I think probably the other one would have been fine. I was going to add 4 more solar panels to the other one, which was steel, in order to run it at 32 heat units per tick. But I don't know. I think it's just better to run the Invar one, because also we're going to probably set up more reactors in here eventually. And I would just like to have like as much distilled water production as possible. So that one will probably also upgrade at some point. But yeah, this guy I think is running at 64 units per tick. So he's producing a lot more water. I also put an axle here, which I should hook up a tachometer sensor to, which I actually don't have on me, but I should go make one. I thought I made one. Maybe I didn't. I don't know where I put it. But yeah, that's all good. So this guy is full. We want to kind of have him a little more full than that, because once this guy starts turning on, it is going to rapidly turn water into steam before that turbine spins up and fills water back into the system. So probably around 80% would be best. I think I could probably get away with 60%, but we'll see. And actually, preemptively, let me set this to equals... Actually, can you set this to... Yeah, equals 0. Or actually, we'll go to less than 1,000. How about that? Less than 1,000 liters. Let's do that. So if you're less than 1,000 liters, you will output redstone, and we'll bring that redstone over here and connect that once we get rid of this thing here. We also want that to be on all the time. We need a redstone torch for that. I'll have to go get some redstone torches. But yeah, another thing I want to do is set up a quantum ring here. So I'm thinking probably we'll just do it on top of this guy. It's like 1, 2, 3, 4, 5, 6, 7, 8. And then we'll get the thing there. We also need a peer-to-peer tunnel. I'm going to use a peer-to-peer tunnel directly on the face of this guy, like that, to extract the power. And that does actually work. The only thing is you need to use an IC2 cable to set that to EU. You can't use GregTech cables, I don't think. So, just PSA, I guess, there. Then I'll use these guys because they don't cause render lag as much as the other guys do. So we'll set that up there. And I have these solar panels so that I can hook up solar energy to this quantum ring. And because this is going to be daytime all the time, these solar panels will produce much, much more energy. So I can run all of the power generation on this side for it and kind of transmit it over to the other side of it. So let's set this guy up. Oh, did I make energy acceptors? Probably not, because I am dumb. Yeah, let me go make some energy acceptors real quick. And then also we could place the other quantum ring. So basically all we need to do is power the quantum ring temporarily on this side with like a diesel engine on a flux dynamo. And then as soon as it's turned on this side, we can extract the power from the other side. Because 20 solar panels running at the same time is more than enough to power both rings all time. So let's make actually a tachometer sensor while we're here, just so we could see kind of how much rotational energy we're getting. Yeah, that shouldn't be too much of a problem. I need to make this one. So brass, I need 8 for the gear. Whoops. Let's get that guy. Oh, I don't know if I did this last time or in between. I can't remember, but I made this little system here to smelt metals into different molds here. So I have gears, sticks, ingots, and plates, and I have it cooling here. This is just the most efficient way of getting the shapes that you want, as long as it has like an associated mold. Obviously, you can't do wires here, but I think, yeah, long term, I won't use extruders. I'll use smelters for as much as I possibly can. And I guess I can use extruders for anything that requires specialized shapes. But yeah, I just thought that was an interesting method of going about it. Oh, I also need a small gear, don't I? Let's do that and get a small gear. Put that guy in here. All right, get you. Put him there. Or no, I think the big gear, I need 2 big gears, don't I? I do. I don't know why I didn't mistakenly Did that. Here. Give me the big gear, please. Alright, there we go. So I think I need a piece of redstone too. Put that guy, I think, in the middle. Yeah, and then it is just 2 plates and a screwdriver. And where's my screwdriver? There it is. So there's that guy, and then we put him in the middle. And we need a double tin alloy plate. 1, 2. We can put the gears in now. Like that. And then we need a piece of glass, which we have, and then just some red alloy wire. Okay. Ah, shit. I should not have done that. Oh my god. Those buttons should not activate when you're holding right click. Really dumb. There we go. Tachometer sensor. So now we can measure the rotation units. There's something else I wanted to make. I can't remember what I even wanted to do now. Oh yeah, energy acceptors. If I can spell. Jesus Christ. Energy acceptor. There we go. 1, 2. So one will be for this side, and one will be for the other side. For now, we'll set up the... Oh, I also need a memory card. Let me get that too. Memory card. Cool. And that way we can get the input on this side, although I don't know if it necessarily matters all that much. Just in case. Actually, did I already have one in there? I did. Amazing. Whatever. Let me put these blocks away too. Okay. So we'll get the memory card of this guy. There we go. And then put him in here for now. So tachometer goes there. And then we want an energy acceptor like there. And we'll put a transformer here. We will reverse him and then wrench him down. And then we want solar panels with their transformers here. So I'm just thinking what the most efficient way of doing this is. Pretty sure, let's see. I'm pretty sure it would be to do it like this. And then like that. Here, let me see. Do I have cables for this, by the way? Yes, I have annealed copper. Cool. Just wanted to make sure. Oh no, actually I need to even put a battery box there. Yeah, HV battery box. Put you there. Put you down. And then where's the HV battery? There it is. So I need the monkey wrench. There we go. Transformer. Monkey wrench. Point you down. Good. Okay. And then I want solar panel to go here. And we want the transformer here. Point you down. Reverse that. Okay. So I think, yeah, the best way to do this is like this. 1, 2, 3, 4, and then point them all into that guy. Good. And then the same thing. Well, let me make sure to completely cover this one too. There we go. And then the other ones we can do kind of the same. So solar panel and solar panel. And then this guy. Fortunately, solar panels can be placed on top of each other with no issues for whatever reason. You can see that guy is still on, even though there's stuff above him. All right. And we can put cables into here. And I need my wire cutter. Like that. And put you there. Put you there. There and there. Or no, that guy is not reversed, is he? There we go. So point that guy like that. And I can put another one. Actually, I could even... I'm thinking I could put this one above, and it would cost me... I think one less? No, it would cost me the same amount. Hmm. I'm just trying to think through this in terms of space efficiency. I mean, it doesn't really matter. Because that one is there. If I put one on top... that's not a big deal. Put that one there. Put a solar panel. Point it here. Oops. Transformer. Nope. That way. Monkey wrench. Point you here. 1, 2, 3. Wait. Do I should have made 25. I only made 20 solar panels for some reason. Whatever. There we go. So this guy should be filling up very soon. Although I think it's probably putting power into here, right? I don't know. Let's see. If I break this and put it back, it should turn on. This should make a net gain. If it doesn't, I can always move these things around a little bit. Definitely that one could be improved. I'm thinking, yeah, if I put it... Oh, wait. Oh, no, I did make the right amount. Okay. No, hold on. I was going to say, I'm not crazy. Surely not. There we go. Get rid of this cable. Point that one up. 1, 2, 3, and then get rid of that. Put this guy here, and there we go. And you should be making power soon. That's an energy acceptor. Good. Good. That guy's online. So whenever this starts making power, it should go to the other side. Okay. And then we'll do the other side. I need to get a flux dynamo just to power the other side temporarily, and then I can immediately turn it off. Do I have a flux dynamo that is capable of running with any of the diesel engines? Flux. I mean, I could run a rotation engine. It's not a big deal. Dynamo. Or no. Diesel engine. Sure. Let me put this down here. I think I'll have to move that carbon dioxide pipe a little bit. Because basically what I want to do... That's going to be EV. That's fine. Because what's coming out is also EV. I think I probably put everything in under chests. Yes. So get these guys. That's the memory card. There's my peer-to-peer tunnel. Okay. There we go. So connect that guy. So he's an EU tunnel. There we go. Memory card. So that will put EV into there. Good. Is that guy also putting EV, or is this Ivy? Yeah, let's play Ivy. This guy needs to go down a little bit. Let me do it here. Probably right there. So let's move that carbon pipe up. And then connect this guy here. That. And then get rid of you. Okay. Perfect. And then we'll build the ring. Although I want to bring down this cable. Like that. And we'll get rid of this. Even though I don't care that much about lead. Yeah, let me throw that in the ore processor. Lead, there we go. And we'll clear out a little more space here. Okay. Should be about enough. Because the ring is going to sit directly here. Like this. So like 1, 2, 3, 4, 5, 6, 7, 8. We'll put the quantum ring core in the middle, and then we'll put this guy here. And what I want to do temporarily is put an energy acceptor here, a rotation engine here, like this, and then I'll just put the dynamo, or the diesel engine here. Okay. And what I also want to do... Well, I don't think I'll even need quartz fiber to, like, power this, because I think it should get the energy back from the other side. I could be wrong. I don't know. I guess we'll see. What am I looking for? Carbon fluid pipe. So that should be putting power into you. Right? You not getting power? Okay, there you go. So that is connected. That's the output side. Okay, that's turned off. So you have 8,000 EU or whatever, AE 16. Energy generation. Yeah, the energy generation far exceeds what we're consuming. I think that's good. Get rid of this. Make sure that doesn't connect. I don't think we need the energy acceptor anymore. It should just power from the other side completely. Right? Looks like it. We'll have to go and look at the batteries on the other side to really get an idea. But I think that should be good for this side. Let me put this shale away. And I can clear this memory card. Put it back in the system. Put away the energy acceptor. Put those away. Combine those. Just clear things out a little bit. Yeah, I think that's good. These are, yeah, they're just going to be empty until I turn on the reactor, probably. Things look good over here. Oh, you know what? I need to go get redstone torches, but I just wanted to check. This battery is filling up. 563, 200. It should go up. Whatever, we'll come back and look at it. I just need a stack of redstone torches and probably some red alloy wire. We're almost ready to turn on the reactor, and I will explain the mechanics a little bit just so it's easier to understand. It's not overly complicated. Let's go get some red alloy wire and some redstone torches. Cool. I think we're pretty much there. So let's go here. Check on that guy. 583, 680. I think that's higher. I think it was 563 something before. 583, 680. 583, 680. So I can keep an eye on it. That's fine. What are we doing for distilled water? It looks like we're up above 80, which is good. We'll use this guy to take a look. Yep, you're completely full of water. Oh, what I also did is put a tank extender here. So this guy is pointed with his main face into the boiler and with its output face here. So it's sort of the same as the reactors. So it's pointed into here so that it becomes part of this tank technically. And then anything inserted onto the main face, which is pointed into it, becomes an output on the secondary face, which goes directly to the turbine. So that is all good there. Now we can start filling the reactors with coolant. And actually what I want to do... Man, let me get a lever too. I want to be able to turn this thing off manually, as well as have automatic switches. Let's see. VER. Yeah, I'll take 2 just in case. Okay. So we're going to have these reactors set to be on by default. These 3 ones here, not the other ones. So we'll do this, this, and this. And then we'll put these guys on here. So they're on by default, technically. No neutrons are coming out yet, obviously, because there's no fuel rods. And we'll connect these guys together. That guy we also want to be on by default. This is the one that we're going to control. Technically, we could put the redstone machine switch here, but it's not going to matter all that much. So we're going to connect this guy to this Geiger counter. And then we'll connect this guy over here to this Geiger counter. And then what we're going to do is turn these Geiger counters to hexadecimal mode because we need to represent values that are over 9,999. And that's where hexadecimal mode is useful. So we need to go to above percentage. So yeah, if we're above a certain amount, so we want to set this to 2,000 or 2C EC, which is 2,000, or sorry, it's 1,100. No, it's 11,500, sorry. So we want 2C E C. And it'll make more sense once I show the way that neutrons accumulate on the breeder rod. But for right now, just take my word for it. Alright. Let me double check that that's actually correct. Hexadecimal. I always just like to double check on this. So 2CEC should be 11,500. Yep, okay. That's just the value that I found that's the best for running this kind of setup. It'll make sense when I actually turn it on. 2CEC on this guy as well. Oh, whoops. I went past it. Okay, so basically what will happen is if the neutrons on the fuel rods, which I will put in after, go above 11,500 on either of these, they will run at the same time, but just for the sake of safety, if they ever go above 11,500, it will turn off the reflector rod here, and then the neutrons will drop on both of the fuel rods, and then it'll sort of go back up. Let's see. I don't need that guy. I need, I want to connect this here. Well, we'll connect that after. It's just going to be, let me go back to wire cutter. That's going to be a safety feature. And then we'll do the same thing for the gibbelometer sensor. I forgot what the pressure is technically supposed to be. Okay. So you're connected. Yep, good. And then we want a lever for manual shutoff. I'll put it over here or something. Where did I have those blocks? I have them somewhere. Yeah, I was originally going to do this with scaffolding so I could reach it up there, but I remembered that I will be wearing my radiation suit when I'm here. So it's probably not a good idea. Alright, so you can see now if I flip this lever for manual shutoff, it'll turn off that specific reflector rod, which is effectively what's going to happen when any of these sensors go on. So if this one goes on, it'll turn that off. If that one goes on, it'll turn it off. So anything that triggers these to go off will turn that reflector off. So now let me explain real quick how this system works, because it's something that most people have not explored, and it's kind of different than most nuclear setups in other mods. So we can take a look at these fuel rods, or where did I put them? They're here. So each rod has a couple stats. So it has emission, self, maximum, and factor. The ones that you really need to pay attention to for breeding, which is, in my opinion, the best way to use your nuclear fuel, is factor. And so you want fuels that have a factor of at least 1/4 or lower, or technically or higher. So, for example, if your factor is 1/4, like 1/4, that is usable for breeding. If it's 1/5 or 1/16, not usable for breeding unless you have like a very specific kind of setup. Actually, yeah, I don't even know if it's useful. I don't think you can use anything except for 1/4 or lower. Uranium-235 by default has a factor of 1/4, which is exactly what we want. So that's going to be your first kind of useful breeding material. Eventually we'll move to plutonium and americium and stuff, but for now, U-235 is the ideal fuel for us. The other stats, so emission is how many neutrons a fuel will put onto all of the rods around it. Self is how many neutrons the fuel rod puts onto itself, which will be measured by the Geiger counter. And also, when you have a certain emission and you have a reflector rod, all of those neutrons that are defined in the self stat will get reflected back onto the fuel rod. So, for example, U-235 has a self, I think, of 32 and an emission of 32. So, if you put one reflector rod next to U-235 fuel rods, you will get 64 neutrons onto the U-235 every tick. So that will equate to, depending on the fuel, it should equate to 64 heat units per tick, which will get transferred into the fuel in the reactor and then go, cycle around. So usually, unless you have a specific type of fuel, the heat that you put, or the neutrons that you have on a fuel rod, rather, will get transferred directly on a one-to-one conversion into heat units, and that will be carried out by your coolant. So for us, we're using tin, which actually only gives us 1/3 of the heat units per neutron, which is totally fine. But that means I have to run 2 fuel rods in order to hit the kind of ideal heat that we need to run this boiler. If I only used 1 fuel rod, it would not be able to actually run this boiler at max, I guess, speed. With plutonium, you can do it, but with U-235, you have to do it with 2 fuel rods in this kind of configuration if you're using tin. Sodium also is useful for this, but it will also get a reduction in its heat conversion. Sodium gives you only 1/6 of the heat per neutron. So if you strictly only care about breeding your fuel rods or your breeder rods, sodium is probably superior because you don't have to worry about heat as much. You can just kind of vent the heat out through this kind of heat exchanger or even smaller ones because there's not going to be as much. But if you want to also make power, which is kind of what I want to do, you are better off using tin or lithium chloride. Lithium chloride is a little bit different than tin. So tin, all it does is give you 1/3 of the heat per neutron. It also increases the divisor of or decreases the divisor of the factor by 1. So, for example, U-235 has a factor of 1/4. You can even see here for lithium chloride. So if it's a molten salt kind of thing, or a molten metal, it will divide, or it'll increase your factor by 1. Or it'll make the divisor of the factor go down technically. So 4 will become 3, 3 will become 2. And the reason you want that is because the calculation for neutrons getting reflected back onto the rod will be increased if you have a higher factor. So that factor ends up getting multiplied by all of the other stats, kind of. So emission, self will all get factored in, and then they get multiplied by that factor. So say you have 64 neutrons on your fuel rod. If you have a factor of 1/3, you will end up having to divide the total neutrons that you have in your self and your emission by that factor. So it'll be 64 divided by 3, essentially. And if you want to be able to increase the amount of neutrons on your fuel rod, you need one that is at least, well, you need reflector rods, because the reflector rods will sort of increase your factor as well. And the tin, because it will raise your factor by 1 value, that will get you closer to a factor of 1/1 essentially. So if you look at the factor, you basically need to look at that as how many fuel reflector rods do I need around my fuel rod in order to achieve a factor of 1. And that will allow you to raise your neutron levels if you can hit that. So for U-235, it has a factor of 1/4, and because we're using tin, it'll be 1/3. So we need 3 reflector rods per U-235 fuel rod in order to achieve that criticality, or that 1/1 fuel factor, or that factor level. And then there's another thing you need to keep in mind, which is sort of the reason why you need that factor. So if you go and look at the breeder rods, they have a loss value. So U-238 breeder rods have a loss of 2,500 neutrons. So what that means is that all of the neutrons reflected onto that rod individually from each fuel rod will have 2,500 subtracted from them. So what that means is that if you want to be able to hit that needed neutrons value, so if you see this needs 256 million neutrons in order to get breeded into a plutonium-239 enriched rod, you need to constantly be able to hit 2,500 neutrons or more on each fuel rod that is putting neutrons onto this breeder rod, or you will not add neutrons to that needed value. So as long as you can hit above that neutron value, that loss value, you will be contributing to the breeding process of this rod. If you don't get above that, you will not be able to breed this rod. So what that means is you need to set these Geiger counters when you measure them to a value that is going to keep it above the loss value of this fuel rod or of the breeder rod. And also you want to keep it as close to the maximum stat on the fuel rod as possible. The maximum stat basically is a value that determines the depletion rate of the fuel rod. So normally if you look at 235, you see it has a remaining time of 10,000 minutes. And it has a maximum by default of 2048. So if you're below 2048 neutrons per tick, you will get that full remaining time on that fuel rod. So you'll get 10,000 minutes out of that fuel rod if you stay below the neutron maximum on that fuel rod. If you go above, you deplete the fuel rod at 4 times the rate. And also I think every neutron you go above the maximum, there's like a linear increase. I don't know exactly how it corresponds to time. I don't know if it's like a linear of neutrons equals 1 minute or something. I haven't really looked at that, but basically you want to keep as close to the maximum value as possible. So what you really need to do is set this value here to get to a level where you can toggle this reflector rod here and then have the neutron value that it drops to still be above the maximum or the loss value of this breeder rod that you're going to put in, so that you can always keep breeding the rod, but you don't go too high above the maximum that you're just like wasting the durability of your fuel rods. And also the neutrons on the fuel rods will obviously deplete, or not deplete, but it'll heat up your coolant much faster. So what I've done is sort of tested to see what level I can hit to get to that value where I can turn off that reflector rod and still keep the needed number of neutrons on the breeder rod, but also preserve the maximum, or, preserve the durability of the fuel rods as much as possible. So hopefully that made sense. I know it's a little bit all over the place. It's not as complicated as it sounds. It's really just like once you understand the values, it makes a little more sense. So basically, to just recap, emission is how many neutrons a fuel rod will put onto adjacent rods. Self will determine how many neutrons are on the rod itself, and those two values will kind of combine together to determine how many neutrons they can keep emitting onto adjacent rods. The maximum is how many neutrons you want to, or how many neutrons you can get to before you start to deplete the durability of the fuel rod faster. And factor is pretty much only for breeding. You can also use it for power generation, but you can look at factor as how many reflector rods you need to be able to hit criticality on the fuel rod, which means that you can sustain a increase in neutrons, a constant increase in neutrons of your fuel rod. So also another thing to keep in mind, I forgot to mention, is fuels other than tin or basically any water-based fuels, or if you use a moderator rod, those will make your fuel rods moderated, which is fine if you want to do these for power, but that makes them incapable of breeding. So if you put this neutron moderator rod into the reactor and it touches any of the fuel rods, like any adjacent fuel rods, those will become moderated. They will deplete 4 times faster, whether it be water or that fuel rod. and they also become incapable of breeding. The benefit of these moderator rods is that you can increase the reflection rate of neutrons if you put more fuel rods around the moderators. So they're pretty good for power reactors, but they're not usable at all for breeder reactors. So we're not using them. We're not using water coolant, and we're using coolant that specifically reduces the factor so that we can actually achieve breeding for these rods. So that's the end of the explanation there for now. We'll go over it sort of as we go through this because it's just going to keep being a recurring theme. And we'll start to go over the better fuels as well because there's going to be like a process to get to the best types of reactor fuels. But for now, we're just using uranium because it is what is available to us. Thorium, by the way, which we also have, cannot be used for breeding. It is impossible because it has a factor of, I think, 1/16 usually. You can see there, I think the factor is being affected by the stats that are rotating there. So you can see water or tritiated water. Oh no, actually it is 1/32. So yeah, definitely impossible. You can see even with tin or sodium, the factor is 1/31 because it decreased that divisor. But still not possible to use for breeding. That's the same for, well, yeah, just for thorium, basically. This is the only fuel rod. So you can't use thorium for breeding, but it is pretty good for power, just a steady source of power. You can see it lasts for 100,000 minutes. So as long as you stay below that maximum, you can sort of just use that as a constant source of power. You can also use cobalt if you want to do a constant source of power. We might do that. I really like building reactors, so I'll probably end up with a couple of them. I vastly prefer them to fusion, so yeah, we'll see what happens. But for now, I just want to get this one started because I'm very eager to start breeding fuel rods. So yeah, let's take this guy off and put on my radiation suit because when you turn on the reactor, it has a range of radiation. And actually, I'm going to open this up so I can leave with my hazard suit because I am going to need to keep this on basically whenever I come to this dimension now, which is probably a mistake to do this, but yeah, whatever. So yeah, let's see. We have full water. We have an emergency shutoff. I will turn this guy to fill vertically adjacent tanks so he can put the molten tin. We will connect that guy so these guys fill with tin. Why are you... Oh, there we go. So now these guys are all filling up with tin. If we go down here, we can also check the bottom one. You do need a sensor to check with the universal extenders. But yeah, this guy's connected to this tank, so you can see he's got 64,000 liters of tin. This guy also has the same. This guy has the same. And this guy over here has the same. So they're all full of tin. And this guy should be... Yeah, he's got 2% of his coolant in there. Very good. I might get more coolant eventually, just so we can have a more robust coolant check system, but it should be okay. So let's screwdriver... Actually, no, we'll leave him there for now. We'll just connect this red alloy wire here. I want to double check that I actually connected this here. Yeah, these are all connected, I think. So they're connected up. Yep, connected up. And you are also connected up, right? Yep. Good. Just doing a quick check of all these things, because once this guy starts going, it's, you know, important to make sure it actually works. Alright, this guy is generating water. Is this guy filling? Yes, definitely. Okay, so both sides are powered with that, I think. I can check with my network tool. Yeah, looks like more than enough. Very good. If I have to, I can add more solar panels, but I don't think I will need to. Okay, so I think we're good here. We can start this reactor. So first I will put the breeder rod in. One thing to note is that I think if you put stuff in when it's... Oh no, I think you can add stuff in when the reactor is running, but I don't think you can pull stuff out without turning it off. But I think it should immediately turn back on because we have it redstone controlled. But we'll see. So we have a U-238 breeder rod. We'll put it in this slot. Oh no, we can't. Interesting, okay. What's the best way of doing this? Actually, yeah, I don't know why. It's good that I have another lever. I can use this lever to control these ones. I don't really need to be able to toggle these automatically yet. These will eventually be on their own like toggle, but for now I think I'll just do it like this, and I'll keep them on wire cutter. There we go. Because for when you put the redstone torches on these, they become inaccessible on the top, which is kind of stupid, but it's fine. Let's get that guy. There we go. All right, so now these are off, and we will point the wires down into them. Good. And we'll do the last one. Okay. Really, all that will matter is this rod here. The other ones, unless there's like a fuel problem, really shouldn't matter. They will generate, or not a fuel problem, a coolant problem. I don't foresee that being a problem, but yeah, we can figure something out. I can figure out some kind of toggle here. I mean, realistically, I could even have a redstone torch pointed into a block and then just use like that. Like if I did this, hold on. And then did this. Cut this guy. And then pointed that. And then pointed this. So this guy on, off. We'll leave him on. Put the redstone torch there. There we go. Yeah, that effectively does the same thing, and I can use this for control. I can point any of the controls into this guy. Or I guess into this. Yeah. But for now, we'll just leave it on manual. I don't really think it'll be a problem. Alright, so these guys are good. We need to put the breeder rod in. So put it... Are you serious? Hold on. I definitely should be able to hit this thing. Why can I not get it on this side? Is it... Hold on. Maybe it's because I'm going from the side. This has happened to me before. Let's go like this. Do that. There we go. And then if I go this way instead, that should be a little more accessible, I think. Like that, and like that. I think that should allow me to access the fuel slots. There we go. So there's the breeder. And you can, if you need to, you can use pincers to extract these out manually. You can also use robot arms to extract them automatically, or I guess retrievers. Actually, that takes quite a lot of durability to pull that out. So yeah, there's the breeder rod. We'll put that there. Then we will put, well, that's a reflector rod. Let's get the fuel rods and also just put all this stuff here. Okay, so we have a breeder rod. I'll get the Geiger counter out. And, 2 fuel rods. Okay, so these guys, let me stand here. There, and there. So those guys are off right now, but if I turn them on, the reactor will start up, and you'll start to see neutrons will build up on the fuel rods first, and then they will start to build up on the breeder rod once we hit a certain threshold. And actually, let me put this guy here just so it's easier to see. Both of these fuel rods will build up at the exact same rate, so it doesn't matter that we don't see that one. It has a control switch on it just in case, I don't know, whatever might happen, but really, you just need to monitor one as long as you have it exactly set up the same way here. So if we turn these on, you'll see that neutrons are starting to build up. It will not build up on this one until it hits a certain value. And also, if we take our magnifying glass, we should see that coolant is starting to flow out. So hot molten tin is coming out, and it's going into here, and then it's bringing molten tin into this guy. And you'll see this guy starting to boil steam inside of himself. And let's see over here. So, yep, we're getting neutrons. It builds up pretty slowly at first. I think this guy more or less has, like, linear increases. The calculations are a little weird to, like, determine how many neutrons it builds up, but it's pretty consistent from what I've seen, so I haven't had any issues with it when I tested it. You can see this guy is building up pressure. Got distilled water. This guy is way more than enough to take care of it, but, you know, we have the shut off just in case. And really, that reactor rod there, the reason why it acts as, like, the sort of total shutdown switch is because criticality is only possible with 3 reflectors, like I showed before. So if you turn that off, they become subcritical and they stop being able to build up neutrons. So even if these rods are still on, as long as that rod is off, they will not, they will still emit a little bit of heat and neutrons, but really not that much, and they will never go above like a certain value. But you can see here, because we're above that value of neutron there, we're starting to build up neutrons on the fuel rod here, or the breeder rod. And once this gets to 11,000 neutrons, that rod will turn off quickly, and you'll see it'll drop the neutron value. You just gotta wait a second. And it'll go down to like 100 or something, which is fine. We actually want that to happen so that we stay above the, the minimum level. There we go. You see it turned off, and then it went to like 228. So we could technically drop this value if we wanted to. It would be fine because we would still be above the minimum breeding value. But this temperature, or this neutron maximum level, seems to be pretty good for me in terms of like how it's able to run the boiler. So I just keep it there. I don't really care all that much if it depletes the fuel rods a little bit faster. The uranium-235 is kind of infinite in a way, because we do have like a bedrock source of it. So once we want to, we can set up a bedrock drill and it wouldn't really be a problem. Plus, it lasts so long. It's just not, there's not really any worth in it. So there we go. You can see we're starting to build up. And if we really quickly grab that breeder rod out, you would see we have been contributing neutrons to its needed value. So you can see it's dropped a little bit. So it'll take a little while to breed that, but once it finishes breeding, it'll turn directly into a plutonium-239 enriched rod. So all we'll have to do with that is, if we go here, the plutonium-239 enriched rod, we'll centrifuge it, we'll get all of the zirconium back, so that's, there's no loss of our fuel rod material or anything. And then we'll also get plutonium-239, and we'll get back a little bit of U-238, I believe, yeah. So it's not quite enough to just do 1 or 2 breeder rods. I think you need like 3, actually no, you can do it with 2, that'll get you a plutonium-239 rod. But we will use uranium for a while, just to get a couple of these so we can have multiple plutonium rods. And also to run plutonium, well, you can run plutonium in this exact same setup. You have to do it with 1 rod because it emits a lot more neutrons. But it should be fine. Let me just make sure these guys are full. Yeah, you can see this dropped because there's like a constant flow of tin, but it's fine because these are all full of coolant. Oh, this guy is... Oh, no, he's fine. He's filling back up. Yeah, I will add a little bit more molten tin just to make sure this never, ever runs out of coolant. And then I'll add a switch here to toggle the rod just in case. And you can see this guy is running, and he's outputting a bunch of rotation units. And this guy should be transmitting the power to our main base. So we're all good here. I'm pretty confident that this will never have any problems, so I'm fine with just leaving it for a second. Let's go back to the main base. Those reactors, by the way, do emit radiation. I don't remember how far it is, but I think this should be far enough to avoid it. So we'll go back and we'll double check that this is actually emitting power, and I think we should be good there. And looks like it is. This is also emitting power. I think one of these is on. Yeah, that's on. But this should rapidly charge those batteries now that we have that kind of power coming out. If I want to, I could put an EU sensor on it, but it should be fine. But yeah, that's pretty much it for the reactors. I'm pretty happy with having that on, and I will allow that to run for a while. Oh, let me switch. Oh, fuck. I messed up. Yeah, this is why I made iodine pills. I think I forgot to put them in my ender chest, so I'll have to go and grab them. But yeah, this is what happens when you get irradiated, by the way. This is what I dealt with before. So yeah, I'll have to mark the range of radiation for this, and make sure I have my suit on at all times. Sorry if you can hear my cat, by the way. She's trying to get out. I have to go let her out in a second. Do I have iodine pills here? I think I have them in a chest. I forgot to put them in my inventory. Yeah, this is why I made those pills. My Radaway, rather. That should remove the radiation. It looks like I have pretty bad radiation, though, so it may not be enough to just have 1. Let me take 2. I think I have radiation 3. Let me eat 3 of them. So yeah, it's pretty bad. You don't wanna get irradiated. But yeah, pretty much that's it. We'll let that reactor run for a little while. We'll get the fuel out of it, all the byproducts. And when I come back, we can start building a second reactor, potentially for plutonium, or we'll reuse the same one. But plutonium is much easier to work with in terms of fuel. You only need one rod. You can reuse the same setup, really, and it produces pretty much the same amount of power. So it's pretty good. And then we'll make americium after we get plutonium, and it should be good. But yeah, for now, I will cut it there, and I'll see you guys next time.